this particular meetup or session is focused towards the familiarization of what is Azure ML, what are the different components, and how it is different from many other clouds, or how you're doing it online. So this is where this session resides in the complete paradigm of what I want to actually achieve in this meetups. Slides is actually very exhaustive set of slides for the 3 workshops that we discussed. They're like around 5 more sessions. So this is more not session specific. These are workshop specific slides. I'll not be covering all the slides over here, but I'll do a better job in terms of taking you to an actual Azure portal, walk you through there, and then actually taking you to the code side of it, so that you get like some ideas of how deployment happens. There are actually multiple combinations of deployment, you can say architectural or design patterns available in Azure. We'll cover one very basic one, and then we'll give you some highlights of what are the other possibilities, and those other possibilities will be covering hands-on in some of the other sessions. So very briefly about different offerings of ML. So today we'll be covering the Azure Machine Learning Studio and Azure Machine Learning Services. Services is more towards CLIs or the SDK side. So everything that you see on Azure is actually powered by backend services and their internal deployment of those things, and those have a manifestation either in the form of services that you can invoke through your SDK or CLI, or you can interact with them in your studio. And we'll actually see cover both of them. So we'll actually invoke a particular model and register it, and we'll see it both in the SDK and we'll see it in the Azure portal also. Besides these, there are other offerings also that will not be covering in this particular session, which are Azure Databricks, which is like a complete Databricks is provides enterprise services for Spark, and that is one of the organizations that has made Spark very famous. So that will be mostly the Spark side of things. Apart from that, there is an HD Insights, which covers the whole big data paradigm, including big data ML. There is also data science virtual machine, in which we have like a whole environment ready for data science, so that you can just spawn it and start using it. And there are a lot of server side, especially SQL server side offerings, which are ready with a Python integration, such that you can run some very basic models and Python codes directly on SQL servers. We'll not be covering the later 3. Apart from these 5, which comes under the ML, there are some AI offerings also, which are cognitive services for AI. And we'll have like another session for that. We'll not be covering this in this particular session. So data science virtual machines could be actually invoked in 2 different ways. So there is, if you want to try it without any charges, you just need a free account in Azure, and then you can request like a leased data science virtual machine as part of their learning. You can get a release of this, or you can actually this comes under the free tier, in which you can open a workspace. You can actually get a virtual machine from there. And these virtual machines, besides having all the environment ready for with your notebooks, also has the integration of many of the deep learning packages within it. And also there are 2 variants of it, the Windows one and the Linux one. Windows one will also have like Windows Microsoft specific tools like Excel and other things also embedded, and SQL servers embedded into it. We will be covering mostly the ML Studio and the ML services in this session. So ML services, this is actually what Azure is trying to do, and that is what a unique point that it is trying to set itself in the enterprise space. If you are coming from AWS side of machine learning, you'll see that here the implementation is quite different. In fact, some of the similarities that you'll find with AWS would come in terms of SageMaker. So anyone would have experience with AWS SageMaker. They actually deals with something called estimators, which are ready-made models for a different framework, and then you can invoke those models, train those, and deploy it. ML Studio starts taking it into a type of game altogether, in which once you define a ML workspace, right from your models, estimators, data, to even your training and training upon different clusters, even Kubernetes based training, is actually encapsulated or abstracted at a different level, which is specific for ML. So all of these things, so for example, if you want a Kubernetes cluster, you can have a direct compute Kubernetes cluster for any of your applications. But if you want it specifically for machine learning, instead of going through that route and doing a lot of groundwork to create a cluster and deploy apps on that, you just invoke a like Kubernetes cluster within your machine learning workspace, and then it just become like a matter of one single line of code to deploy things on Kubernetes. And similarly, it's not about just Kubernetes, but anything that you need to do with machine learning. Once you have spawned a machine learning workspace separately, everything can be done like with just a click. And we'll be covering some of it to make you understand like how ML Studio and Workspace is different from other ML offerings, whether in on-premise or with different clouds. So we covered this. I'll just speak briefly upon it, but we'll be covering these in some of the other sessions. So these are like the traditional data science role. So you need to have a data engineer, data scientist, and developers. Until some time back, even Microsoft had these roles distinction within themselves. This has actually changed very recently. In fact, the new role-based certifications that Microsoft has rolled out, in case of machine learning, you do not have these three different roles. Or at least you do not have the last two roles separately. You have one single certification, which is like an Azure certified data scientist. And the reason for that is with the new way that Microsoft or Azure wants to take data science, these roles are indistinguishable. So the same person who is actually drawing the model and creating the model can also deploy it in the same works. And that is why I believe Azure-based machine learning is started becoming very popular amongst enterprise applications as well. And once you actually develop a particular model within a particular workspace, there are different ways that you can consume it and deploy it. Same model that you have made is containerized, so everything works with the container, and those containers could be either directly deployed on say Kubernetes services as a Kubernetes box, or it could be deployed as a container. So the first one is actually a container. This is Azure container instances. This is Kubernetes, or this could be actually directly invoked as a service within your workspace. Also, nowadays there's a latest trend on the edge. In fact, this is a long-term offering on the edge. People have been trying to put different models on the edge, and as the edge becomes more stronger in terms of processing power, you can actually host a lot of different new types of model on that. Traditional open source way that we used to do it is using say Raspberry Pi and microcontrollers like Arduino, but both of them are not very optimal because Raspberry Pi you cannot actually have like a embedded directly on the edge on the sensor. It's too expensive and too computationally expensive, but and that is not required. So that is if you want to host a complete Windows operating system on that, you can do it. So and Arduinos are not there when it can actually invoke machine learning model on a simple level itself. That is where special types of, you can say, they come under the category of microprocessors, but they, from a power efficiency perspective, they come very close to microcontrollers, which are called FGPs, field gate adapters. And you can actually host your models and deploy your models on FGPs as well, and they will work on the edge. So the same way that you train a model, you just have to put over there. This requires special privileges on your workspace. So this is what we will not be able to cover in this particular session. Apart from that, if you just want to test it, you can host it as an REST API, and if it's a very small app or just a service that you need to use, not a complete pipelines and everything, you can just host it as a REST service. Or you can also have your scoring or the inferences go directly as a function as a service on Azure. So these are all the ways possible with just some few clicks once you have actually invoked a particular workspace there. Here I will actually take a break and make you walk through the complete portal and some parts of the portals that will give you a greater understanding of what we are going to cover next in the slides, and it will become faster for us to see this. But just to understand the broader perspective where the workspace live, where we're going to show it. So within your Microsoft Azure account, you have to create a subscription. If you do not create a subscription and that's a new account that you have, you already will have a ready-made subscription, which is a free tier category. So this is also where Azure is slightly different from other clouds like GCP and AWS. So in AWS, for example, you have like a free tier services. You register your credit card, and once you actually exceed your free tier services, automatically it will start billing on your credit. In Azure, it's slightly different. They take credit card just for the purpose of authentication, but that credit card couldn't be charged till you actually create a subscription, which is chargeable. Okay, so initially you'll have only like a free subscription over there, and if you want to use any of the chargeable subscription, you will have to either upgrade that free subscription or you have to create another subscription. So any of the resources would be a part of one single subscription. Okay, so within the subscription, you create resource groups. Again, those resource groups would be tied to one, you can say, billing account or something. And within those resource groups, you can have multiple entities being created. We'll be covering over here in this particular session only a workspace, which again is a collection of resources. It's not just one resource, a collection of resource, but that is opaque to us. We can actually just forget that so many things are underlying, and we can keep working automatically. Things will start going into the right place where they should go. So, for example, if you are doing machine learning on AWS, you will have to get into a lot of IAM key managements over there, and then you will define roles on each and every resource that you are using, and then connect to those particular application related and so on and so forth. Which is also true if you try to do into Microsoft Azure as different pieces together. But once you have spawned a particular workspace takes control of a lot of different things automatically, and then you are relegated of those responsibilities, and workspace can actually manage everything within it. You can actually bring other resources also which are outside of your workspace and connect it to your workspace, and we'll cover one basic example of those ways also. Now I will actually pause this present and I will go to my Azure account to show you how does these things work. Just a basic implementation of it. Okay, so with Azure services, you'll get services tab like this. Let me know if my screen is not open. I'll just enlarge it. Okay. And this is your Azure Machine Learning Workspace. If we actually explore it more, you earlier had a lot of different types of machine learning services, but now they have been bolted into one, which is your machine learning workspace. You can use a lot of other things, but now it is more easier with your machine learning workspace. The symbol will look something like this. So if I open this, these are the workspaces that I have created within the resource group. So as I mentioned, resource group is more tied from, you can say, billing subscription perspective, how you want to tie those resources, or from an authorization perspective, and any of your workspace will be part of one particular resource group. So for example, if you're working in an industry, so and you have like separate billing accounts for different departments, you can actually have one resource group for one billing department, and within that, if you have different products, so maybe you have say operations department, so you're doing forecasting for a particular outbound operations, so that can be like one workspace, and if you are trying to do one day assessment, could be another workspace, or this could be like one if you are in horizontal. So that is how you actually deal with different types of workspaces. Within workspace, so subscription level, you can actually just say whether it's a paid subscription or where the subscription should actually bill to. But within the subscription itself, there are for a workspace, there are two different types of workspace. So one is a basic workspace, and the second is the enterprise workspace. Enterprise workspace will give you some added benefits that we'll be covering later in the slides. And within the workspace, that what you need to pay focus is on these parts that we'll be actually using very extensively. So workspace comes at the highest level of abstractions, and within workspace you have something called experiments. Experiments are nothing but your you can say a training job. Again, job is like more of the terminology that we use either on premise or in engineering language. But if you have like a training script that may actually produce multiple training runs and training models, all this will be called experiments. And within each of these experiments, you will have runs of these experiments. And these terminology and what I'm specifying, this actually is the same terminology that is used in the SPK also. And we calling the classes at the top level classes by these names, and all these will be subclasses to the. Now, what makes the workspace related concept easier to do a lot of things in machine learning as compared to a direct, you can say, an account-based subscription of any other cloud provider is that you have your compute which is embedded inside your workspace. So now, even if I have an experiment, I can just define an experiment, and whether to run it on my local system or to run it on, say, a particular VM, or to run it on a complete clusters of GPUs. That is just one click how I define where you need to run it. And automatically, since it is a training run, you can also have the flexibility built into it that once the training is over, just release the resources on it, so that you're not built into it, for which you don't have to actually write custom codes or do any of the manual pipelines work to do all those things. Now, models is an essential part of any machine learning. So whenever you are running an experiment, your aim is to actually generate a model that could be used in different ways. So in the earlier slide that we covered that the models could be deployed in different ways. But before you deploying them on different ways or using them into different areas, we have to first register those models. So any model that you register becomes a part of your workspace. Then it is not immaterial how it was created, whether you created on your local system and registered it, or you created in one of the experiments that you ran on GPU or CPU or any which ways. Once it's a part of the workspace, then you can use it in any which ways that the workspace allows you to do it. Okay, and once you've deployed the model, this will come under your deployments. We have not covered the pipelines images part for now. We will keep it for later. Activities is nothing but your monitoring. So again, as compared to other cloud providers which have like a monitoring as a centralized piece, where irrespective of what type of application it is, you have to maintain separate monitoring. For any of your machine learning things, monitoring actually can be part of the activities, so that it becomes easier to see what is happening over there. The second thing that to see is on the security. I'll not make this session very heavy with security because I understand that is a slightly more involved topic, but I'll try to make it easier in the terms of a demo over there, just to make you familiarize of what are the security provisions available that you could use for different types of applications that you're building. I'll go back to slides now, and hopefully the next slides will become slightly more easier once you have got a taste of how the portal looks like and what are the components of these workspace. And I'll just go slightly faster now because I'm slightly low on time. So the basic components of your workspace is, as I showed you, compute targets. Now, compute targets could be of different types. They can be like a single machine that you are doing a compute on. It can even be your local machine, and that is when you can actually use a similar set of APIs, but it's calling it a local compute. Or it could be clusters. There are different types of clusters per se in Azure. One is a compute clusters or batch clusters, which will be used mostly using for training different types of jobs, and then you can set like what you want the configurations of those clusters within your code itself, and whether you want them to scale down or you want them to remain static over there. And then there's something called inference clusters. Those could be for scoring, and there are different types of inference clusters also. Or if you have something outside of your machine learning workspace that you have created specifically for the particular product, you can actually have like a workspace which is a machine learning instance outside of your workspace. Then we covered the experiments. These are nothing but your training runs, which will produce either models or do some computations. Pipelines is the orchestration of different types of, you can say, scripts that you want to invoke. So, for example, if you are trying to run a complete pipeline or like sequences of machine learning tasks that completes a particular application. For example, you are suppose getting your images from a particular place or maybe a public repository, and then you are trying to transform those images, scale them, and then do some pre-processing, and then you are running a convolutional neural network on those images. So these are now three different steps. Although you can actually have the same compute units do the three different steps, but it is highly suboptimal to do it that way. For the simple reason, you do not actually require a GPU to do transformations on a particular image, and you do not require CPUs. It will not be optimal to run the actual code on training on the CPU. So you additionally want different types of computes to be focused over different types of applications, such that you do it in the least possible time and also in the least possible cost. And that is where those pipelines could be bifurcated into different steps. Each step can go into different types of compute, or it can use like different types of abstract. Then a major problem in machine learning per se, because by the nature of machine learning that the training happens separately and the scoring happens separately, is on the data set. How do you actually use particular data? How do you retrain your model? So even if you have a policy-driven model training, that will have to actually refresh the data with each of these runs, and then the model would be actually transported to your scoring services. So how do you actually deal with type of distributed data if you don't want to get into even the distributed data services like Hadoop or even Spark distributed data systems? So that is like a blob-based system that is automatically attached to your workspace, and these blobs, the locations in these blobs could be abstracted as a data store or the data set, which could be across different types of training runs, experiments, and scorings. Okay. Since I expect initially you all be working on the pre to get yourself familiarized with Azure machine learning. So most of the things that we'll be covering in all of these sessions, not just this particular session, are covered into free tier, except for some of the advanced things like some of the components of explainable AIs or GUI based designers for the pipelines. But even within the free tier, there will be limits. So once you actually exceed those limits, you'll have to upgrade it if you want to keep using it further. We have covered this workspace part, and once you create a workspace, if you see this part over here, download config.json, this is the easiest way that you can actually authenticate even your local Jupyter, and we'll be local Jupyter for this particular session, because I believe that is the way that all of you would like to get started with. You have your existing some of the models that you like to directly use with the Azure ML. So just download this config.json with your workspace, and we'll cover the steps later on. Will we not be doing this configuration preparation in this particular session? This will be just a demo, but once we actually take a workshop on this, then that is when we'll be doing hand holding on these things. So there are different ways that you can actually train a model. The most basic way may not be in the enterprise condition, but once actually getting yourself familiarized, so most basic way would be that you actually train a model locally on your system, and then you directly register that model on the Azure Workspace, so that it could be deployed in any of the ways. More simplest deployment could be a REST service or a container-based REST service. I'll be using the container-based REST service for this demo, and we'll cover the later parts or other parts into some of the workshops. Some of the more advanced ways that we'll be using in an enterprise environment would be actually using some of the compute-based training as well, and when we'll be covering some of the deep learning based exercises, that is when we'll be using that. Just a second. Yeah. But for this particular demo, we'll just use local models that will be training on a system and then uploading and registering on the workspace. Obviously, that will be completely automated process through scripts, but we'll also show you the counterpart of it. How do you do it manually on your portal if you want to do it, or just